Hi everyone, welcome to Math Spellbook. I'm your host Peter, and basically we're going to do some physics problems today. Hopefully you guys are having a good Monday so far, and hopefully you started the day on a good note. And if you did, I'm just gonna give you some positive vibes anyway, just so that you need it. Anyway, let's just get started. So, today, hopefully the sound's okay. Okay, my mic is fluctuating, cool. Because I remember when I was streaming on my last channel, my mic wasn't on, and unfortunately no one in chat told me that my mic was not on. But, that's what happens sometimes. Like, my mic wasn't, I guess my mic wasn't connected to my OBS. Because, when Windows updates, sometimes it just messes around with some of the small things that you don't notice. Anyway, today we're going to do basically just physics problems today, because I felt like I was out of practice with physics, so I felt like I should just do some physics problems. Because, why not? Just exercise the muscles. Hey, non-dairy neutrino, how's it going? What's the best part of your day so far? My Monday has been great, because it's a snow day, so I get to play Factorial and learn about the difference between Julia's distribution. Oh, nice. That sounds interesting, actually. I'm glad it's a snow day for you. Like, hopefully you don't have to shovel too much. Because, I think, the thing as an adult, when it comes to snow, usually, when it comes to snow, shoveling is usually the hardest part. Alright, so the book I'll be using is University Physics by Young and Friedman. So hopefully these problems will... Because we're going to start with kinematics, because I have been out of practice with physics problems for a long time. So, I mean, I never really formally took a course on it, on paper, but I did take an online course on it. Of course, I didn't get any certification or whatnot, but... I did learn a lot from that, but I feel like I have to get back into the practice of actually doing physics problems. Because I think what I'm afraid of with physics is that I'm afraid that, I guess, I don't want to say I understand the math, but I feel like my math knowledge sometimes creeps up, and I worry that if I have a mathematical idea, I'm afraid that it's not equitable to I guess the physics problem, because obviously I have to think more like involving the natural world rather than just thinking that there's a mathematical world where I can just pull stuff out, but I don't know, maybe I'm just thinking too much. Anyway, I think I'll start the clock. 45 minutes. All right, let's go. Let's just make this problem a little bit bigger. I think the problem with, because I'm trying to take the problems directly from the book, by highlighting them and stuff, but the thing is that it doesn't take the whole thing, so sometimes I have to retype stuff. So, I mean, it's a lot easier than me just rewriting the whole question. Okay, so from the pillar to the post, let's see what, I also have the book in front of me, so I'll rewrite whatever it is that the stuff is missing, and I see what else is missing here. So let's just type in here. Plus x, positive x direction. Okay, let's see. Run the average speed of... Here we go. Yeah, it's also missing here. I don't know why it's missing. I don't know, whenever I highlight stuff, it always misses some stuff in the book. I mean, at least it got the majority of the question. Let's see, run... Yeah, it keeps missing the numbers. 4 meters per second to to a post and calculate A, average speed to the pillar to the post, and B, average velocity to the pillar. Oh, it put all this stuff here. Let's see. I want to make sure that all the numbers from the problem are here. Okay, it looks like all the... So we don't need this. Alright, here we go. Alright, enough of me yammering. Let's actually just think. Oh, there it is. I was about to say, where'd I put my pen? Okay. From pillar to post. Starting from a pillar. Okay, so let's just draw a little pillar so we know. So we start from a little pillar here. Yes, I will use stick figures. You start from a pillar, run 2 meters east in the positive x direction. Okay. At average, your speed. Okay, so the final distance. Yeah, because we don't have to put a negative because it's in the positive. At average speed. Well, it's not initial, it's like average. So we'll just put an A there for average. Then run. Oh, okay, so. So we run, so from, starting from the pillar, you run, okay, 200 meters at an average speed of, okay, so we'll just leave this on one side, and then you run back, so I think we'll just, instead of F, we'll just put that x1, and then this is x2, and then you run west, 280 meters. Actually, I'll remove my VTube model. I sometimes hate it when I like look at my tablet, it shrinks, so that way it won't distract you guys. That way it looks like I'm shrinking. It's like, oh, I'm back, I'm huge again. With an average speed of, yeah, I put the negative sign there. So there we go. And then 4 meters per second to a post. Calculate your average speed from pillar to post and your average speed from pillar to post. Alright, so I think we're just gonna erase this and make this a pillar. Because they say pillar, so it's supposed to be this big, or at least look as big as a pillar. And then we'll put a little. Oop, nope, I didn't want to do that. And then put a little post here. Hello, Tyrion. How's it going? What's the best part of your day so far? Yeah, I just took my little VTube model off so it doesn't like distract us. Why are you kicking, you know, dairy, non-dairy neutrino? Why are you kicking him? Or why are you kicking them, I should say. Best part? No, don't do that, guys. Don't do that. I want all of us to enjoy the problems here. So from the pillar you start, and this is a 2-dot problem, so it's supposed to be a challenging one. Okay, so I enjoy causing problems. Well, I hope not, otherwise I might have to kick you out. Please be nice. Please be nice. Because we're all here to learn. We're all here to learn. Or just get stuff done. Get stuff done. Better watch out for this steering guy. He's a menace. Just ask any chemist. It is this. Now, fellas. No need to get into that. No need to get into that. Okay, so starting from the pillar, you run 200 meters east in the positive X direction, right? At an average speed of, and then we go back and run 280 meters with an average speed of 4.0 meters per second to a post. Okay, so I think we're supposed to draw another one over here. We'll draw another one over here because it's supposed to be we go back because we have a pillar here and we have another post here. So this first one, we run from pillar to post, we run this way, and this is supposed to be 200 meters. Well, actually, that other post doesn't look to scale. So we would turn back. This is 200 and all the way. We'll go over here. Yeah. 280 meters. I mean, yeah, because then we would cover this much. I should probably put negative. Yeah, I should probably put just negative 80 meters. So that way we know that's like 80 meters past the pillar. Yeah, I feel like nothing has changed for me. I've been busy finishing masters in teaching. Oh, nice. Actually, non-dairy neutrino, I forgot, like, what is your master thesis on? If you don't mind me asking. Currently doing some thesis working, investigating the difference between... It might be, I need like 50K to apply for a master's program in applied maths at Washington University. Is that like the online program? Because I think I saw that like once. I think I saw like an online program about applied masters in mathematics at Washington University. Yeah, it's online? Oh, okay, I was right. Yeah, I was considering it once, but at the same time I was like, no, I don't have money to pay for school. I think the only reason why I would go back to school for like math and physics is because I would like to be in the lab. Well, not really in the lab, but I would like to be in a setting where I can just talk to people and like learn together with my peers. And probably like talk to professors and ask what they're researching on, even though I'm nowhere near their level. Okay, so the question is, calculate your average speed from the pillar to the post. Pillar to post, and your average velocity from pillar to post. Oh, okay, so now it's making you differentiate between speeds. So I'll just erase V so we don't get confused. Why don't we put S for speed? So we have to know the... So you have an average speed. So average speed, you just have to add those up. So we have an average speed of 5 meters per second, and then we run with an average speed of... So... Oh man, yeah, like paying for school is usually like the hard part. But don't try not to cause too much like chaos, Tyrion, please. Please don't. My thesis is developing a way to use multiple computers and... Oh, that's really interesting. In parallel via a novel method. Oh, did you guys come up with that idea? Because since you're doing your master thesis, I'm guessing this is sort of like a new frontier for you guys. Unless someone thought of it already and you guys were like, oh, that's a brilliant idea. We should do that. We should implement that. Okay, so your average speed from pillar to posts. I mean, we already have the average speed, which is like... Unless it's saying from all of them, like basically, and your average velocity from pillar to post. Unless it's talking about the post that's in the back. I think it's basically telling us, like, you know, what is the average speed in total. If I'm being totally wrong, you guys can tell me. But I think that's what it's asking for, so... I think the average speed of the whole trip. Because I know with average speed, it doesn't matter what direction it goes. But then you also have to divide it. I forgot about that part. I think you have to divide it by the average. Because we have two speeds. I got a federal aid for my master's, so that might be an option. Granted, they are... Wow. I'm glad you got some funding for your research, though. That's really hard. I got a couple... yeah, I'm paying the loans still from my MS... Oh, dang. I'm sorry to read that. You know, student loans always kick, like, scholars' butts, I swear. It's just that, like... Why is it that it has to be so much, you know? It's like, we're just going there to better ourselves. I understand you have to have someone pay for the education and stuff, but it's like, does it have to be like this over, like, the same, not like the same, well, technically it can be, like, almost as much as a car or a house? Come on. So the average speed... Because they don't need the time. And there's only two values. So do we divide it by 2? Because then it would be just 9.5 meters per second. It is the price of a car or 2. Yeah, right. This method isn't new by tech standards. It is parallel algorithm was initially developed in 2001, but I'm implementing it in the Julia language, including both version that runs on the CPU and GPU. Oh wow! So it's like basically has like multiple calculators in one. You're using the main power of the CPU, but you're also having the GPU help out like with the major like tedious stuff. I mean, that's what I'm getting at, because like from what I know of GPUs and CPUs. Or if it is a private college, yeah, the 100K, yeah. I don't know why they're trying to make college so expensive. They keep making it seem like, oh, college is the place where you're going to get a job after you graduate. And in fact, nope. It's just basically for you to get an education. I mean, for me, I don't think universities should basically give their pitches like, oh, you're guaranteed a job if you come here or something like that. Because honestly, like, in my personal opinion, I think just university is just meant for you to go to grad school. But of course, if they market themselves that way, then there's no way they're going to get students to come in, because it's like, oh, I don't want to be in school forever. This is supposed to be the last part of my youth where I actually just study, and then I just go into, I guess, the quote-unquote adult world. To the post and your average velocity. I mean, the average velocity, we might need the time anyway. I mean, we're not accelerating, so... So the first part, because usually it's distance, and we're not accelerating, so we just have to have this, so... Well, actually it's both, so it's like that, and then... So time... I mean, they're both gonna be the same. Oh, I gotta drag my mouse. There we go. Thank you for the Begone's non-dairy neutrino. Trying to use the... I'm guessing that's from that server. I'm guessing you both found me through the Physics O server. Trying to manifest power I know I don't have. Yeah, gotcha. Okay. So yeah, we're gonna need the time. What fun! Oh yeah, I forgot to click on my tablet. I always hate that. Whenever I go onto a different monitor, I have to make sure that I click back into my tablet to write things. So it's 200 meters. Because I know I gotta do this 2 times. Meters per second. So that's around like 40 seconds. Yeah, it's like around 40 seconds. Okay, so for the time it takes for... I mean, I'll first do it, because we already have 40 seconds for here, but... I'm just gonna do it over here, because I know we're gonna need the negative sign for later. And then... I mean, I think we can do the velocity first, because I think it's much easier. Because when I try to think back on speed and stuff, it's just like, ugh. I think that's what physics do, is like you're so used to the metric system and you're so used to like thinking of vectors in a different way. And... well, actually they're both negative. Yeah, because then you run back at that... Oh, okay, so it's just going to be positive either way. So that's 70 seconds. Okay, so in total, the time would be plus 40. Seconds. Oh, your admins on the physics O server. I see. That's why you both are both very knowledgeable. I could barely even get through one problem. You guys are probably like used to doing like textbooks like practically every semester. Physics office hours was the official name. Oh, okay. I see. Okay. Now I see why this problem is the challenging one, because you have to think about both speed and velocity and think of them as different entities. Okay, so we did the times, and together that's, yeah, together that's like 110. But then of course the direction changes, so we're going to have to keep those times separate for now. So the average speed from pillar to post, I'm guessing it means the last post. Like this post here. Because we go from here and then we go back. So our final position would be -80, because we go 200 forward in the positive direction, and then we go 280 back, which means we're going to cover this this side, and then we're going to go 80 more. I have not been in school in decades. Ah, I see. I have indeed many textbook problems. I struggle then. I struggle now. I will struggle in the future. Speed is magnitude of velocity. Yeah, always. Yeah. Thank you for reminding me, Tyrion. Thank you for reminding me. Get something to eat if you can. Get something to eat. So I guess we can use the time to basically determine the velocity. So velocity will be distance over time. The average velocity. So if we divide -80 by 110 seconds. And then with speed, you have to basically add everything, like the distances you traveled. So instead of being like -80, it would probably be like it would be like 480. And then it would be 480 meters, and then you'd have to divide that by the amount of seconds that you did to travel there. Because I remember with speed, you have to like treat it like a little bit differently than velocity, because speed doesn't have a direction. Because like Tyrion said, it basically it is the magnitude of the velocity. I mean, if I... Alright, so let's see if these answers make sense. Because I don't know if they make sense. So we have negative, so our placement is negative 80 meters because we went back west. And then, yeah, we take the time, divide that with is it talking about averages, right? Yeah, it's talking about averages. So you need to, you need the initial and final values, yeah. See, at the average speed of 5.0 meters per second, and then run 280 meters west at an average speed of 4.0 meters per second to a post. Calculate your average speed from pillar to post and your average velocity from pillar to post. Not instantaneous velocities? No, not instantaneous velocities. Yeah, because it says in the question, A, your average speed from pillar to post, and B, your average velocity from pillar to post. Yeah, maybe the velocity's not right, because the velocity is like really like tantalizing me right now, because we have to know the position. So we'll just move down and see if we can do it a different way, because first we go from 0 to 200, and then we go from 200 to 80. Well, we go yeah, then we go to the opposite direction, which leads us to okay, maybe I'm mixing my brain up a bit. I got the Feynman path with the basic calculus book. It's going to be my reading in the next few days. Oh, nice, nice. Yeah, I thought, like, that book I have to actually start reading too, actually. Because I think I only got through the first chapter. It looks very doable, yeah. Every time when I'm on Amazon, I basically like look at the book that I'm curious about, and I try to make sure that I read inside it. See if there's like, if it's like really interesting stuff in there. Because sometimes I get books that basically said, oh, you can learn physics with this amount of calculus or this amount of algebra. And then I buy it, and it turns out to be like one of those books that kind of doesn't, it does teach the material, but it doesn't give you enough problems to work with. It was also $14, so I just need to skip a good meal to afford it. True, true. You're willing to go all the way for knowledge. Yeah, I don't think I did this right. Cause the speed looks fine, it's just the velocity looks really funny. Yeah, because we go from 0 to 200, and then we go from 200 to 280 in the other direction. So technically, if you were calculating the velocity from here, or calculate the time, I should say. Because yeah, that would still end up with like the right times that we end up with. And then for the other side, divide that by negative. Oh, okay. So maybe that's what I was missing. So it takes 120 seconds to get to the other side. So then if you add those together, then that's a different time then, so it's like plus 40 seconds, not 1.4. So that gives us 160 seconds. Yeah, get some coffee if you need to. Usually I prefer tea. I prefer tea, actually. I'm not really a caffeine person, that's why I don't drink coffee. I know a lot of people drink coffee for mainly work-related reasons. Let's see what this ends up being, because we might have to change the speed too, actually. About 0.5 meters per second squared. So that's a little bit different. So the average speed, I mean, technically we traveled like that many, and then 160 seconds. Let's see how that turns out to be. Uh, 3 meters per second. Where did you get this problem from? It is different from the Yelp problem set. I'm doing problems from university, the book University of Physics by Young and Friedman. I feel like these are much closer. I mean, these might be... I feel like these might be alright. I mean, they're not too different, but at the same time, it's like... I might be off. The ones we did before were, the Yale set. Yeah. The one we did in our physics session was from the Yale set, yes. The ones we did before were, yeah. Yeah, I already read that. Sorry, I was about to read something twice. Well, I do have the answers, so let me take a look. I'm so used to getting problems wrong, because, like, I guess, like, it's just my way of basically, like, understanding where it is that I am, like, stuck at. Oh, whoops. Alright, here we go. Oh, I was right the first time. So, yeah, so it's like 70 and 40 seconds. Getting them wrong is perfectly okay. That is how ideas get soaked in the brain, yeah. So, yeah, we were correct the first time. So it was actually this answer. Let me see, where's the speed? Oh yeah, so this, oh, so it's these answers, okay. So, okay, so, alright, so I did wrong here. Interesting. I guess the way I calculated was kind of like different. Let's see what they did. Let's see, eastward, right? Yeah, they did the same ratios that I did. The average speed, yep, yeah. It's like they added the distances together and then did the, yeah, that's what I did too. Okay. So I guess I should have went with my gut and just basically just went with it. But it's just amazing that the average velocity was that. But then again, like when I calculated this, like it was kind of close to the ballpark. So yeah, this one was not really necessary. I think I was just kind of like, I thought I would get like different values that were kind of closer to each other, I guess. Okay. Well, I don't know whether I would classify that as me getting it correct. I mean, I did the calculation and I did get the numbers. I guess I was just trying to check my work, I guess. But then again, sometimes I feel like... Alright, so it's usually moments like this I have to ask myself, like, okay, what did we learn here? Because, I mean, I did get the problem right. The thing of it is that... Why did I doubt the answer? That was the one thing that I had to ask myself. Why did I doubt the answer? And I think the reason why I doubted the answer, because the difference between the velocity and the average speed... I thought they would be, I guess the value, I thought they would be a little bit closer to each other. Even though I know velocity is like, you know, the change in displacement. I guess it's because it's just against my intuition, I guess. Which I think in physics is usually normal. It's like whenever it's against your intuition, sometimes like, it's better to like think of it that way. Like even though we're not used to it. I don't know. I'll let you guys be the judge. Did I get that problem right, or did I not? You could say I'm being. You said you can judge whether I got the problem right or wrong. Because for me, if I were grading it, I wouldn't know what to grade it, because I would be like, oh wait, there's like another answer here that probably shouldn't be there. Or maybe I'm just not really good at checking my work, which is probably the latter. If you give me money, I will say you got it right. Oh, thank you. Thank you, Tyrion. I appreciate that. That's very supportive of you. Because I'm trying to do the challenging problems. I'm not trying to do the ones that, like, are just, like, easy. Because, like, I'm trying to do, like, the ones that have, like, 2 dots instead of 1 dot. I haven't done the ones that are, like, 3 yet, though. Nope, don't do that. Don't do that, please. I just want to highlight one problem, not the whole section. Yeah, that's the problem with highlighting. It's just that I can't highlight without it being, like, touching the other part of the text. And I'm like, no, just leave that alone. Okay, we'll copy this. Because it's just being really annoying. Then I'll just copy this. I think we'll type out the rest because apparently well, actually, that's supposed to be alpha and beta, but I guess they don't. I guess they wouldn't let me do that. Where A is 1 meters per second, and B is equal to 0.5 pop dot meters per second squared. Oh no, cubed. Right? Yeah, cube. Oh, okay, yeah, we got cube there. Okay, calculate the average velocity of the car for each time interval. Break time, but I'm just gonna finish typing up this question so we can work on it the next session. Hopefully you guys are enjoying me struggling through these problems. And if you guys are new to the channel, please drop me a follow if you can. That way I can be productive for your productive sake. And if you want to join our Discord, you're more than happy to do so. And it doesn't matter what you're doing. You could be working on a piece of art, or you can be like just working on your research, or you can just be chilling, just enjoying the vibes with us. It's alright. Something looks dodgy about those units. Hey, hey, Mix the Pick. How are you doing? How you doing? No, you don't have to do that, Tyrion. You don't have to do that. If your phone's ringing, like, answer the phone. You don't have to unfollow and follow again. Don't worry about that. You're gonna make lasagna? Cool, cool, cool. Yeah, actually, like, I have, like, 2 books with me right now. Like, this is break time, so we'll just chat for a while. But how you doing, Mix the Pick? What's the best part of your day so far? Actually, when you said about the units, like, what do you meant by that? Like, what units would we get if we plug them in? Oh, okay. Well, that's what it says in the problem. Actually, can I drag my... Can I just place it here? No, I can't. Because I'm actually using the Mito app. Wake up on my walk now. Oh, cool, cool, cool. I'm glad you're getting your walk in. Are you sure? If you give me money, I can unfollow. No, don't worry about that. Don't worry about that. I'm just glad you're here anyway. I'm just having a cough drop in my mouth right now, so I think I'll put my model back up. There we go. I'll probably turn it off when we get started on the problem. Let me just click this. I think we'll just drag this over here because I noticed that chat was blocking the problem a bit. Oh, it's 3 p.m. Yeah, time for a walk. Yeah, definitely. No, don't worry about it. Don't worry about it. You don't have to keep asking me that. Yeah, get a meal. Get a meal. Use that money for food. Use that money for food. I know this whole in the ground place. Oh, okay. Actually, when you plug seconds to T, it makes sense. Usually, though, I would imagine T is unitless. Ah, I see. I see. That's what happens. You know, thank you, autocorrect. That's what happens sometimes. Yeah, actually, like, I have like 2 books that I ordered, but they're pretty tough. Cause like the title caught my eye. I'm probably gonna like study up to the point where I can actually learn from these books. The first book was A Mathematical Journey Through Differential Equations of Physics by Max Lenin. And then another one is Mathematical Physics with Differential Equations by Yisao Young. So when I flip through these books, I'm like, wow, there's like so much like math in here. But at the same time, it's like, am I up to this level yet? And I don't think so. I actually like the Mathematical Journey Through Differential Equations of Physics by Max Leonard because it has these cute little pictures of Newton, Leibniz, I think it's Descartes, and Einstein, and I think that's supposed to be Schrödinger. Okay, walk time. Then I'll make food. Time to lurk. Okay, no problem, Tyrion. Enjoy your walk, and hopefully you get some good food along the way. But yeah. Let's see. What's the question say? A Honda Civic travels in a straight line along a road. Its distance x from a stop sign is given as a function of time by the equation. It looks like calculus. They are taking averages of things. Yeah, because like the first part, because like I'm doing it by section. So the first part is displacement, time, and average velocity. And then I think the next section is supposed to be average and instantaneous acceleration. And then let's see. Yeah, so and then like the 4th section is like motions of constant acceleration. And then the next section of the questions is freely falling bodies. And then we go into velocity and position by integration. I think that's about it, yeah. And then we get more challenging problems at the end. I'm not getting any food unless I can break into... Oh, oh my gosh, Tyrion. Instantaneous acceleration. Nature report. What do you mean, mix the pick? What do you mean by that? Because mix the pick, you're basically like into like because you already have your bachelor's in like computer science and math, right? Because I remember when you joined your the server, you typed that in your introduction section. How do you measure instantaneous velocity and thus the instantaneous acceleration of a particle? Oh my goodness. I'm not at quantum mechanics yet. I'm actually excited for that though. Like, to be able to answer those questions. Because honestly, like, I was reading about a little bit about topology, like, before I came on, actually. Like, I mean, when I woke up this morning, I was reading a little bit about topology. Topology is pretty interesting, actually. Even though, like, obviously I am not at the level of understanding math proofs yet. Like, I'm reading this book called Topology Without Tears. And I feel like I understood, like, the first section. Like, the definition of a topology and, like, what it's supposed to represent. And sometimes when I, like, read math books, I feel as though it's, like, I don't have the physical intuition to back it up. So I'm trying to do physics problems so I can understand both physics and mathematics, and then I think it would be cool to like basically merge like abstract mathematics with like, you know, like the ideas of physics that are there, you know. Just a fun idea to play with. Like fun ideas to play with, but you know, obviously math's definitions are very, very stringent. Well, in physics, like things are like not always mathematically predictable at times. Because I think the mismatch of like when they were trying to determine how much dark matter and dark energy in the universe, it was like a big huge number that there was a mismatch within both theory and experiment, which is really bizarre. It all builds on each other, even in surprising ways. Yeah, because I think for me, it's like, if you were to ask me if I'm more of a physicist or a mathematician, I probably wouldn't be able to like answer the question, because like I like physics because it has like a structure to like how reality should behave, but it's done in a mathematically beautiful way. Whilst like math, like it doesn't need physics to actually like be relevant. It's just its own subject for its own sake, you know. But I do like the idea of actually putting mathematical ideas on paper and just seeing how it works. Like basically, like if you have a physical idea, let's try this mathematical technique and see if it will solve anything for this physical problem. And if it doesn't, it doesn't. But if it does, then ooh, let's see what happens, you know? But then again, like I do like playing around. Like I think I want to learn physics because I want to be able to play around with like, I think the equations. But of course, I think like many people that are into physics, they probably are like, you know, physics is not mathematics. My view on dark matter are that the whole theory should be treated as the evidence for it. What do you mean? Like, what do you mean by that exactly? I'm also very curious about what quantum gravity is, you know, because obviously a lot of people have different opinions on what it is. And some people are working in different fields on what they think it is. You know, because obviously when I got introduced to physics, I did catch the string theory bug. But at the same time, it's like, if it's not proven to be true, then I'm willing to accept it. I don't hold it like as like a big religious type of thing where it's like, oh, it has to be string theory no matter what. But I'm actually curious to know math because I want to know the beauty within string theory. Just the beauty. Like, I want to understand why people think it's beautiful. Or maybe people think it's a big mess. That's also another interpretation people might think. But loop quantum gravity is also interesting to me as well. Like, you know, because like the big theories out there, like, you know, I want to know what that makes them tick. And, you know, like, if I know enough math, then I'll be like, oh, let's play with it a little bit. Let's see what happens if this parameter is this, or this parameter is that. No one is yet to observe it in isolation, so the basics of physics first. Yeah, that's true. Yeah, because I think, like, I'm willing to, like, do problems just to basically, like, get myself up to speed to, like, understand how the physical world works. But of course, I know I'm not going to get to the level where people are just researching it. Like, you know, like people are obviously in the libraries researching endless hours just to see what it means. I guess my life's project would be like just learning physics and just basically learning math in order to like try to explore in both domains. And I think that's fair enough, you know. And hopefully, like, my journey, like, you know, streaming my studies and stuff is, like, you know, as much fun for me as it is for you guys. Because I feel like with, like, you know, the math community on Twitch, it's, like, it makes me feel as if I'm working towards, like, I guess a higher plane of existence in a way. Because, like, none of my friends love physics or mathematics. They like the ideas, but they don't really like to get into the, I guess, like, the trenches of it. For me, I'm willing to, like, actually, like, do the physics problems and stuff. But of course, I'm not gonna do, like, all-nighters and just study it. Unless I get really, really obsessed with it. I do like reading more. Doing problems, I think, is, like, if it's too much of a tedious problem, I end up, like, just dropping it for a while and just let myself sleep. And then just basically just get back to it the next day. But then I would do something else if I still get stuck on it. That's why at most, I would probably do like 5 problems if I just get them right consistently. But if I get stuck on a problem, then I probably will just, if I finish that problem, I either get it wrong or I get it right. And if I get it wrong, I look at the answer and I'm like, oh, that's how they did it. But then I would just like I wouldn't do any problems after that. I would probably just like, just do something else. Oh, you said so fix the basics of physics first. I didn't see the fix part. Makes the pick. I thought you were saying like to me specifically. I thought you were saying like no one has observed like dark matter like consistently. So I mean like hasn't seen it or observed it. So you have to learn the basics of physics first. I thought you were saying that. I mean, like, you know, like, it's like the same thing with math, you know? Like, why don't we learn proofs instead of just, like, doing calculations? But then back then, they had to learn calculations first. I think they learned that from the Egyptians. And then, like, I think, like, during the Greek times, they were developing proofs on how to prove mathematical ideas without the need of numbers. And then, like, to me, I think like proof writing is probably like the bread and butter of math, but then I end up questioning, why is it in school that we have to learn how to calculate with it? Why can't we just learn proofs then? You know, like in school. But of course, I think that would be too difficult for like students because it would be too abstract and kind of too technical. All right, before we start our next study session, I'm just gonna use the restroom for a brief minute, so catch you guys in a minute. Alright guys, I'm back. So I'm not going to turn my model back on. Instead, I'll just turn on the study clock and we'll just begin with the next problem. Okay. Hopefully you guys didn't wait that long. Alright, so let's take a look. A Honda Civic is traveling in a straight line, so let's just... I guess we'll just do a little crude drawing like always. Yeah, we'll draw a little car. Make it look a little cute. Draw little windows. Doors. There we go. A little windshield. Actually, that doesn't look right. Looks like a little cute little creature. Doesn't look like a car. Yeah, let's just make it more boxy. Put a little windshield, windows. Let's put a door. There we go. And a little headlights. Why not? Okay, so a Honda Civic is traveling straight on a road. Its distance from X from a stop sign. So we got a stop sign. Just write stop on it. And its distance X from a stop sign is given as a function of time. So I'm guessing this is xt, and then xt is equal to the they put alpha and beta, so we might as well do that. So alpha times squared minus beta, where a, or alpha, I should put alpha, where alpha is 1.5 meters per second squared, and beta is 0.0500 second cube. Calculate the average velocity of the car at each time interval. And okay, so this one is position. Yeah, because it says the distance from the... Oh, okay, so I guess they just want us to take the derivative of this. So the derivative of xt time, so that leaves us with 2 times alpha minus 3 beta. Okay, so they want us to calculate the average velocity between... Okay, so the first one is from 0... Ooh, that's too close. So the first one is going to be t equals 0 to t equals seconds. Okay, we're doing seconds. Okay, that's good. I usually hate it when we have to convert things. I have no problem with it, it's just that it's more work. But then again, when you're working endlessly on equations, everything is work. I mean, everything is like a tedious, like basically like moving factors around and like trying to like juggle things. Okay, so we have to calculate A and B. So A so we have to determine the average velocity of so we're gonna have to put this equation on the top, yeah, so we're gonna have to do final velocity over initial velocity, and then that with the difference of time. So yeah, that should give us the, no, that's, what am I doing? Because it wants the average velocity. Yeah, calculate the average velocity of the car in each interval. So basically we just have to calculate. Alright, so we just have to do it for 2 seconds, because it's gonna, if it's 0, then basically everything goes to 0. So x, oh no, well actually it should be v, vt, it should be v I think of 2 seconds. So I think that would be the instantaneous velocity. Then then 2.0 seconds minus 3, 0.5, 0.500 m3 times it's like, so 2. So v2 because this crosses out, yeah, and these two cross out, so that is it at, and then at v at 0, it's just 0. Down here, then do this. So if we do this for 4, minus 0.500, and then that would be 4 squared, that would be 16. So the average, so the velocity at that moment, and obviously still 0, and then c, so technically we have the velocity of, so it'll be point, and then this one, alright, so now we have to calculate the average velocity in all of these scenarios. Okay. So the average velocity, I think you basically have to add the velocities up and then divide by the average of like how many there are. So it's like basically it would be 2. So the average, well, I think it's like we have to add all the speeds up and then basically divide by the average, which is like the amount of different speeds that we got, I think. Hopefully I'm getting that right. Let me see. Calculate the average velocity of the car at each time interval. Because I mean, we get 2 results. The thing is, because I mean it goes from 0 to, so I think it's like basically it's still average because that's how much it goes, like within that amount of time. Because if you divide time by that, then it's just going to be a distance. Yeah, it would just be a distance, and that's not what we're looking for. I mean, hopefully that's right. Let's take a look. This is problem number... What problem is this? This is number 2.6. Should have wrote that down. So that way I can look up the answer. So 2.6. So how do we set it up in our problem? Let's see. Find x at each time. Oh. I mean, C I got close to. But the other two I was totally off. Yeah, because I thought I would just integrate. I mean, differentiate. But I guess they don't want you to do that. Yeah, they basically say calculate the distance. Yeah, they basically say calculate the distance with each time. Okay. Okay. Yeah, this is what I mean, because like for me it's like, oh, I know velocity is the derivative of distance, But of course, like, this is when the knowledge of the math doesn't serve me well. Because the way they did it was that you calculate the distance and basically you take the distance from time. So technically s of 2 and x of 0, it would be 0. And then you have to calculate the distance. Yeah, I thought I was being clever, but unfortunately that doesn't work. That doesn't work. So we can get rid of this, because that didn't help us at all. I mean, it did help us get C, but at the same time it wasn't like, I guess that wasn't the intended purpose. So then we end up with this, and then basically we have to divide that by 2 seconds. Which gives us 5.8 meters per second. And then for no, wait. I think I did the calculation wrong. Okay, so alpha divide that by 2 seconds. Yeah, there we go. Okay, so I have to remember this in case I have to calculate the average velocity again. Yeah, because I thought I was being clever by basically just like taking the derivative of this, but then again, that's instantaneous velocity, not average. So I have to remember doing the average, you have to take the distances and then divide it by time. Velocity here is 2 point. Yeah, and if you did it for the other one, yeah, because you would have to take the distance between both of them and then subtract it and then do 2 seconds. Yeah, so you still take the difference of the times. Okay, So that one I didn't get right because I was trying to do some clever trick and it didn't work. Oh well. We learned from it though. So we have to know that the average velocity is the difference between distances and over the distances of time. Okay. Because I hardly use that. I mean, we do use it, but at the same time, it's like I hardly kind of like formulate it that way. I guess it's because like I haven't exposed myself to enough problems. Where's my mouse? Oh, my mouse is over here. Okay, now we're doing instantaneous velocity. Drag this down here like that. And now, can I highlight the problem? Okay, instantaneous velocity. And now we take the mouse. I just want to grab this. Can I drag this? Thank you. Okay, it's in the right place. There we go. Let's see if all the info's in here. Because sometimes when I highlight these things, they don't let me get all the info. Let's see. A ball moves in a straight line, the x-axis. The graph in... Yeah, we got. Let's see if we can copy this graph. Actually, I don't think we can though. Hey, Don Does Math. Been lurking a little bit. I've got a dentist appointment. It goes soon. Just wanted to at least say hi. Okay, no problem. Don Does Math. Actually, I'll give you a shout out. So if you guys haven't heard of Don Does Math, not only is he a math streamer, he also plays video games. So be sure to give him a follow. If you got a math question, he will more than happy to answer. Did it went through? Did my shadow went through? Guess not. No problem. I am more than willing to shout out anyone in the math community, because you guys will teach me as much as teach others. It didn't pop up on my end. It's thought that it count. Yeah, that's weird. Like, why isn't it letting me shout out anybody? Yeah, I'm typing it out and I don't think I shouted out anyone else. If I could do it through my stream elements, let's see. Let's see. There we go. Oh my goodness. At least my stream elements works. I guess like Twitch probably has either my Twitch or like maybe Twitch is like working some bugs with the shoutout command. Yeah, I love the exchange of information that happens with Twitch. Yeah. True. Well, hopefully you get through your dentist appointment, okay? Yeah, like, I got the previous problem wrong, but then again, that was basically my own misconception. But, you know, I don't stream just to basically show you guys what the problems I get right. I stream basically because, obviously, I got to show you what I'm learning, and I still have a lot of learning to do. Okay, so a ball is moving straight in a straight line, so we can't copy I can't copy and paste the graph from the book. So I guess I'll just drag, no, I just want to drag this. I guess I'll drag my, and actually also, probably I'll just drag the answers too. They all don't need to share my one browser. Anyway, so the question is, a ball moves in a straight line, the x-axis. The graph in figure, yeah, right here, this figure, shows the ball's velocity as a function of time. What are the ball's average speeds and average velocity during the first 3 seconds? Suppose that the ball moved in such a way that the graph segment after 2 seconds was negative 3.0 meters per second instead of positive 3 meters per second, 3.0 meters per second. No problem. Thanks, Don Does Math. I'll ask you what the, like, I'll just before you go, I just will ask you this one final question. What was the best part of your day so far? And then you can get back to your dentist appointment, or waiting for the anticipation of the appointment. Okay. So find the ball's average speed and velocity. Okay. So we've done a question like this before. Okay. All right. So. Yeah, probably enjoying in a cup of coffee. Nice. Well, I appreciate you lurking. Always appreciate people that are lurking, just observing my progress. And if you guys are also lurking, could you drop me a follow, please? If you like math or physics, and and you can also join our Discord server as well. You can just type in !Discord, and in fact, I'll do that for you, so you guys don't have to go through the trouble. So we automatically get our YouTube channel, but I put the Discord up for you guys as well, so you guys can also subscribe to my YouTube channel in case you miss some of the parts of the stream. Because I think after this study session, I will probably end it for today. I try to do 3, but at the same time, I think for this time I'm just gonna do 2, because I'm gonna be streaming on my gaming channel tonight too, so I want to conserve some of my energy for that. Okay. So back to where we were. Let's see, what is the ball's average velocity during the first 3 seconds? Okay, so I guess we're gonna have to look at the graph again. So the velocity is 2 seconds. So for 2 seconds, it goes 2 meters per second. So okay. So from 0 to 2 seconds, we'll just write it this way. Actually, we should put 2.0 seconds. We were going at 2.0 meters per second, and so from 2 seconds to 3 seconds, we were traveling at what, positive 3? Yeah, positive 3. So positive 3 meters per second. Right, okay. Suppose the ball moves in such a way that the segment after 2 seconds was instead, so what is the average speed and velocity of the ball? Okay. Alright. So we got the speed, so it was traveling around that. So now I think we have to actually calculate the distance. We have to calculate the distance and then take the average velocity of that. So this is 1 second, so it was done for 1 second, and this one was 2 seconds. So technically we should do v1 times t plus v2 times t. That will give us the final distance that we need. Because, well, actually, Thank you for the follow. Thice? Thice21. Thank you for the follow. I appreciate it. And if you're in the chat, like, what's the best part of your day so far? So now why am I mixing myself up? Yeah, I'm mixing myself up. So we already got the speed of travel, like the velocity speeds. Hang out with your cat. Nice, nice. That's always good. So let's just do the calculation. I'm not gonna bother writing it all out. So we get 2 meters for 2.0 seconds plus for 1 second. So that is 7 meters. So what is the average speed and velocity during the first 3 seconds? Okay. So then we get the average velocity, which is 7 meters, and then 3 seconds. That's not gonna be nice. Yeah, it's gonna be like 2.3 meters per second. But it's good that you're having fun with your cat. Like, do you have just one cat or do you have many cats? And also, like, I think your name is pronounced Thighs? Is that is that how you pronounce it? Thighs21? Like, if I'm wrong, please tell me. I want to make sure that I pronounce your name properly. I have one, and my roommate has one. Oh, that's cool. I heard that cats are, like, very easy to take care of. I mean, sure, you have to still take care of them, feed them, and whatnot, but it's pronounced like if you shorten Tyson. Oh, okay. So Tice? So Tice21? I'm guessing that's how it's pronounced. So suppose the ball moves in such a way that the graph segment after 2 seconds, instead of finding its velocity. Okay, so yeah, this is, I know this was gonna happen. They don't usually, like, whenever I copy a question down, it usually doesn't go the way I want. Okay, so suppose the ball moves in such a way that the graph segment after 2 seconds was -3, yeah, instead of positive. Find the average velocity and speed. So I think we still have to find the speed. So we got the velocity, we just have to find the speed. Hey, welcome back. Welcome back. So Thice, I'm wondering, like, how did you find my Twitch channel? I'm just curious. Did you enjoy your walk, Tyrion? So average speed. So then, so I think it would be like, and divide that by 3 seconds. Just think average speed. We'll just put S for average speed. I know S could represent anything else, but okay, so I think that's for A. So I think it's this and this. Okay, so for B, so then if we had this, and then It's the same equation. We just have to change V2 to be negative 3 meters per second. It was good. It was 70 to in mid-February. Wow, that's good. That's good. Just looking through math stuff on Twitch. Oh, okay, that's good. Do you just like math, or do you like other subjects involving math? Thies. Or Tice, I should say Tice. Sorry. So, if we take... So, 2 seconds plus negative 3.1 second. So then that would be 1 meter. So then we would end up with an average velocity of 1 meter over 3 seconds. So it's just 1/3 meters per second. And then for the average speed, we would still get practically the same result, I think. Anything math related, really. I'm doing some physics next semester, so I've been getting into a lot more of that lately. Oh, nice. Are you an undergrad or are you a graduate student? Like, because you said next semester, so I'm guessing you're like either an undergrad or like a graduate student. Unless you're still in high school. Yeah, because then basically the magnitude, because usually the velocity is the one that cares about the negative sign, but not really speed. Because I think it would be pretty much the same. Yeah, because the average speed is like you add them together and then you basically divide it by the time. I don't know, what am I doing? I think I see what my error was. With these problems, I keep mixing up time and distance. I mean, velocity and distance. Because then basically if you just do the math, because the distance itself is like 7 meters. Yeah, so then that would practically be the same. So the average speed and the average velocity are the same. But this one, it's going to be a little bit different because it's a negative symbol. So basically, yeah, undergrad, majoring in environmental earth science. Oh, okay. Like how? Like, are you enjoying that major? Like environmental earth science? Did you just start it, or like are you like in your 3rd year already? Yeah, it's fun. A lot of geology and math. Nice, nice. That's good, that's good. But you're only just majoring in environmental earth science, right? Like, you're not double majoring or minoring in anything else, right? You're in your first year? Nice, nice. Usually, like, freshman year is usually the time that you kind of enjoy it because you realize that you're, like, in a big environment with a lot of students and you can meet a lot of people. And also, like, you can engage with the faculty that are into the geology department. Am I confusing myself? Which is usually what happens whenever I do problems. Because the last problem we did... No. Actually, I should zoom out. Yeah, we took the distance and... Yeah, we added the distances together and then divided by the time. Yeah, that's what we did last time. Might minor in math or urban planning. I'm not sure yet. I mean, like, the thing of it is that I think you should just do a minor in something you just enjoy. Because usually, like, with, like, if you're trying to get a job or anything, like, obviously, like, a lot of people try to get a job, like, after college. And usually they don't really care about, like, what your minor is. It can help if it basically is, like, something that supports your major, but at the same time, it's like, I think you should just minor in thing that as something you enjoy. So, you know. I mean, if you enjoy urban planning, then go for urban planning. If you enjoy math, then just go for minor in math. I mean, if they do care about your minor and they see that their math is like your minor, then it'll be like, oh, this person like probably knows how to solve problems, you know? So it's either or. You get to choose. So the average speed and the I mean, they're both going in the same direction, so I wouldn't be surprised. Yeah, because I think the last problem we did, obviously we were going one direction and then we were twisting to another one, but this one they were going the same direction, so I think the average speed and the average velocity should match at this point. I think. I think that's the case because they're going to the same direction, so it shouldn't be surprising that they do. But now this time we are getting a different. So we're still going like 7 meters. Yeah, we're still going 7 meters. And we're still going at 3 seconds. The only difference is that yeah, and then it would just result in this. Speed average. I don't know what they actually write down for speed and the variable for speed in physics. I usually go by an S because it's much easier, but then again, I know they use S for something else. Okay, Tice, thanks for chilling with us for a short while. You have a lecture to go to? No problem, no problem. So the average speed is the same. It's just the velocity is different. So I think that's it, but let's just take a look. So this is number 2.9. So we got the average velocity and the average speed. Yeah, they're both the same in this circumstance. And this one, we should get this as the average speed. Yeah, okay, so we got it right. Yeah, so the average speed is still the same, but the average velocity is different because it's changing direction. Okay. Alright, so we're slowly gaining a better intuition of how speed and how velocity and how those work. Okay, so I think that will be our last problem of the day, guys. Not bad. We got one problem wrong, but we got, like, 2 problems right. So, I say that's a victory. That's a victory for today. I mean, obviously, we shouldn't count how many times we got stuff right, because the amount of times that we get stuff wrong is, you know, also a plus, because we're learning from that. So, yeah. I think that will do it. I will do it all for today. So, I wonder if there's anyone... Well, actually, I should let my VTube mono come up. Okay, there we go. Okay, guys, thanks for studying with me today. I know it was a bit shorter than what we're usually do, but I try to stream at least like close to like 4 o'clock. Like sometimes I go into 5 because like I feel like we just need to get into the grind of actually like doing more problems. But today I'm going to be streaming on my other channel, so I will post that up, my Uncle Talks channel. So if you guys are into like gacha games, today we're basically going to complete Withering Waves, so you guys can check out my Uncle Talks channel for like my gaming channel. And if you want to follow my if you want to subscribe to my YouTube channel to catch up what you missed on today's stream, you're more than happy to do so. And also, if you guys are lurking in the chat, be sure to give me a follow if you like math or physics and just need someone to basically be like, I guess, that study atmosphere that you need in case you just want to be able to like just chill and just like study or just be productive in whatever you're doing. It doesn't have to be math, it could be like art or anything like you're making. So let's see if there's anyone streaming any math today. No, unfortunately, there are no math streamers up on my list, so I guess we'll just have to end it today. So, yeah, so thanks for chilling with me today, guys. We're going to be here at the same time tomorrow, so always remember, guys, everyone is precious. You guys are just as precious as everyone else, and I will see you guys in the next stream. So take care, guys. Bye-bye.